apply a potential. If I apply the potential, what will happen? The moment I apply the potential, charge will varies. The moment charge varies, the flow of charge nothing but constitute a current. So this current, this constitution of current the constitution of current due to application of the voltage. So when we apply the voltage, what will happen automatically? The current, the electric charge, the charge will move, that will induce the electric field. So that will induce the current. That means what? V is equal to directly proportional to I. So or V is equal to IR. So R is equal to now V by I, which is Ohm's law. So that means you can measure a resistance of this any wire if you take, you can measure its resistance. So the measure its resistance also with respect to specific resistance also. So how the resistance and specific resistance varies? Resistance and specific resistance. What is the relationship between the resistance and specific resistance? V is equal to IR, R is equal to V by I, rho is equal to 1 by R. So 1 by R inverse of resistance is specific resistance. Then how the conductance and resistance varies? Conductance is equal to 1 by R. Conductance and resistance, rho is equal to 1 by R. So the conductance is inversely proportional to resistance. When the resistance is increases, conductance will decreases. When the conductance is increases, resistance will decreases. That means conductor, insulator, in other words, so conductor, semiconductor, insulator, which will have high conductance, which will have high resistance. Conductance, semiconductor, insulator, 3 I am taking, which will have high resistance, high conductance, high resistance. Huh? No, not for you. Not for you. Because I teach them enough. I am teaching enough for them. I am taking 3 material: conductance, semiconductor, insulator. I want to know which will have high conductance, high resistance. Conductor will have high conductance, no? How the semiconductor? Semiconductor is in between them. Conductance, semiconductor, resistance. So conductance should have a high conductance. Resistance will have a high resistance. So if the conductance are high conductance, means resistance for the conductor will be should be very low, because conductor has in the high conductance. That means resistance should be low. Now we go for here insulator. If we go for insulator, what will happen? Resistance is high, means conductance should be low. That's all. So semiconductor is in between them. So in between the semiconductor, there are what is how the conductance varies now? Now how the conductance will varies? Conductor, insulator, and semiconductor. How it varies now? On what basis it is differentiated? Conductor, semiconductor, insulator. Based on energy gap. Energy gap between the valence. There is based on the energy gap between the valence band and conduction band. So valence band, lower part is valence band, upper band is a conduction band in conductor. Semiconductor, same lower band is valence band, upper band is conduction band. In third insulator, lower band is valence band, upper band is conductor, under upper band is conduction band. So in conductor, valence band and high conductance, low resistance. So what happened to the energy gap? Energy gap is almost 0. No energy gap between valence band and conduction band, and valence band will overlaps with conduction band. If you go for a semiconductor, valence band and conduction band, energy gap is there. That will be very small. If you go for semiconductor, if you go for insulator, valence band and conduction band, the band gap is insulator, it should be very, very high. So that when the when the it cannot able to conduct, it have very high resistance, very low, very high resistance, very low conductance. Why it is? Because energy gap between the valence band and conduction band. So this is normal for all the three bands. So based on this only, conductor, semiconductor, insulator. So based on this these three only, you have found that all the conduction and resistance we can able to calculate. Okay. Now in the same scenario, now if I apply if I heat the material, for example, conductor, semiconductor, insulator, I am taking the material and heating it, okay, which will have so the specific resistance. What will happen when the temperature increases to the conductance of the conductor and semiconductor? Insulator, whatever heat, it is independent of it. So you forget about insulator. Now I am taking about conductor and semiconductor. I am increasing the temperature. What will happen now? Electron. When I heat the material, I am not applying any electric field, nothing. For example, conductor, I am taking copper, okay, I am heating it, okay. Then I am placing back. When it's cooled down, again I am doing the conductance studies. Now I am taking the semiconductor, again I am heating it, okay. Then again I am taking it, again I am heating it and giving back. Once it's cooled down, we can do all the normal process. Example of conductor is copper, example of semiconductor is silicon nitrate, okay. So if this happens, what will happen to the resistance with resistance or conductance? Anything you can take resistance itself, okay. So you understand the question now, okay. You understand my question? What happened to the resistance of the conductor and resistance of the semiconductor when you increase that, when you heat it or increase the temperature? When you increase the temperature, when you are heating means what will happen? First is when you are heating the material, what will happen? The temperature of the material will increase. So when you increase the temperature of the material, what will happen? What will happen to the resistance now of conductor and semiconductor? So the resistance of the conductor will increase. For semiconductor, it will decrease. Why? No, I can't hear you. No, I didn't. For what? No, for conductor, the resistance will